Hey everyone, welcome to lesson 3.5, finding zeros. This time we're going to find our zeros by factoring. Just a reminder that last time we found them by graphing the function and by taking the square root of both sides. Obviously today we're going to be using the factors. So here's a couple of notes about how we find the zeros by factoring. First things first, if you want two things to multiply to zero, then one of them must be 0. Try and think of a multiplication problem that equals 0 without using 0. You can't, not with multiplication. You could with addition or subtraction maybe, but not with multiplication. So we're going to use that fact to set up the equations as multiplication problems. This is why we learned how to factor quadratics. I should say quadratics, not quadratic. For example, if your two factors are x plus 4 and x minus 3, then either x plus 4 has to equal 0 or x minus 3 has to equal 0. Or it could be both of those are true. But as long as it's one or the other, then the whole thing becomes 0. Because if this is 0, then you're basically doing 0 times x and 0 times negative 3, and that's all 0. So as soon as one piece is 0, the whole thing becomes 0. The answers to this problem would be negative 4 and positive 3 because negative 4 plus 4 is 0 and 3 minus 3 is 0. And these are always going to kind of end up being opposites like that. So basically what you're going to do is factor, which we already know how to do, and then set each factor equal to 0. So today shouldn't be that much different than normal. This is the best method to use, by the way, when the equation is in standard form, because then you can't use the transformations to graph it, and you can't use the square root because there's more things than just something squared. So let's take a look at some examples. So we're going to do 6 examples here, and I'm just going to have each one pop up. If you want to write them down, go for it. However, I also understand that some of us aren't going to be taking notes as we learn from home. So whatever floats your boat for this section. So our first example is going to be x squared minus 10x equals negative 21. And we want it to equal 0, not negative 21, because that's the only way that they multiply, like the way that I explained in the last slide. So it has to be a 0. 0 is like a special number. It's the only number that works. So I want to get rid of that negative 21 by adding it to the other side. And then I need to find numbers that multiply to 21. And if you need to, you can make a little list off to the side. I'll show you what that looks like. So we've got 21, and that's either 1 and 21, or let's see, not 2, but 3 and 7. And because we want it to add up to negative 10, I'm going to make everything negative. If I don't make both negative, then it doesn't multiply to positive 21 anymore. And then we've got these two right here. Those add to negative 10. So that means that my factors are going to be x minus 3 and x minus 7. Okay? And then you set each factor equal to 0. So if I want x minus 3 to equal 0, x is going to be 3. Because basically you're just asking yourself what number minus 3 equals 0. And if I want this to equal 0, it's going to be 7. Moving on to the next one. X squared equals 2x plus 15. This time I need to minus the 2x to the other side, and I need to minus the 15, because I want it to equal 0. And one quick thing, I don't want to move the x squared because we don't want a negative in front. That's going to mess up our factoring. So that's why I'm moving the 2x and the 15 instead of the x squared. Then I need two numbers that multiply to negative 15 and add to negative 2. Well, let's see. 15 is 1 and 15, or 3 and 5. 3 and 5 are going to be the ones that I want, and I want the 5 to be the negative so that it adds to negative 2 instead of positive 2. Remember that it's always going to have the sign of the bigger number when you're adding a positive and a negative. So that's why I want the 5 to be the negative, so that it adds to negative 2. Otherwise, it would add to positive 2. Then what number minus 5 is going to equal 0? 5. What number plus 3 is going to equal 0? Negative 3. And on the third one, we have x squared plus 11x minus 26 equals 0. So sometimes it'll be nice and it'll already give you one equal to 0. And this time I need something that multiplies to negative 26 and adds to 11. There aren't very many things that go into 26, just 1 and 26, 2 and 13. I want the 2 and the 13, and one of them needs to be negative, otherwise it wouldn't multiply to a negative 26. And since it's a positive number in the middle, I want the bigger number to be positive. If I switch these signs, then I would get negative 11 instead of positive 11. So this factoring is just like what we used to do. If you're having trouble finding those numbers or understanding what I'm talking about there, it might be a good idea to go back and watch the 3.3 notes again. And then you have what number minus 2 equals 0? 2. Sorry, that's definitely not right. Let's go fix that. And negative 13. Okay. I must have stolen the answers from another problem. And then on the bottom left now, we have x squared minus 64 equals 0. Now, this is an equation that you could also use the square root method for, but honestly, most people prefer to factor it still because this is a difference of squares. And that means that there's no term in the middle. So the two numbers in the parentheses are going to both multiply to 64, or multiply by itself to equal 64, but one's going to be a positive and one's going to be a negative. And the number that multiplies by itself to equal 64 is 8. So we have x minus 8 and x plus 8. Another way of thinking of this is that they add to 0 in the middle. So you need two numbers that multiply negative 64 and add to 0. And then it's just like these problems. And then my two answers are going to be 8 and negative 8. And I'm writing them in the same order. The 8 is coming from this. The negative 8 is coming from this. Moving on. We have 3x squared plus 11x plus 6 equals 0. This is the AC method, or the one where you have to multiply the first times the last, now that you have a number out front. Okay? And I call this the AC method because this is A and this is C. And that multiplies to 18. So I need two numbers that multiply to 18 and add to 11, which is going to be 9 and 2. So what I do is I split up the middle term between 2x and 9x. And then over here, I'm going to take out a greatest common factor of x. And over here, I'm going to take out a greatest common factor of 3. And when I put that number or variable outside, I'm dividing it. So over here, for instance, 9 divided by 3 is 3. 6 divided by 3 is 2. Then I have my parentheses that matches right here and here. So that's going to go out front. And then the other parentheses is going to be whatever I have left on the outsides, which is the x and the 3. And it doesn't matter what order you write those parentheses in. Then I'm going to set each of these equal to 0. When x plus 3 equals 0, it's going to be negative 3. And then let this one sink in for a second. If I covered up this 3 in the front, this one would have been negative 2. And then I have to divide it by 3. So almost imagine as if you are solving this equation right here. Okay, so then you would subtract the 2, and that's where the negative 2 comes from. And you would divide by the 3 in front of x, and that's where the thirds comes from. So it's always going to be the opposite of this number divided by the 1 in front of x. It's really easy if you just follow patterns on this one. And the last one, I'm going to have 2x squared plus 12x equals 14, meaning I need to subtract that 14 to the other side first. And this one's kind of tricky because it looks like it's going to be like the last one we did, except I could actually divide those all by 2 and put a 2 out front. Then I would be factoring this part on the inside only, and I need two numbers that multiply to negative 7 and add to 6, which would be 7 minus 1, or 7 and negative 1. And then one quick thing is, this 2 out front is never going to equal 0. I don't need it to equal 0. I just need the two spots where I have x's to equal 0. So the 2 out there doesn't change anything at all. In fact, I could divide by it on both sides since I have an equation now, but I'm just going to leave it and say if I want x plus 7 equals 0, that's going to be negative 7. And if I want x minus 1 equals 0, that's going to be positive 1. Okay, and then the very last thing we're going to do is look at how to write the equation using these facts. Okay, and before I move on to the next slide, I just want to point out again that these are always opposites. Okay, so those are opposites, those are opposites, those are opposites. Like, to get your answer out of the factor, you just kind of flip it. That's it. Okay, and then down here, it was negative this number divided by this number. There's going to be a couple that ask us to go backwards there. Okay. To write the equation, you basically take these two numbers and work your way back into the factors, like this. Let me clear my drawings really quick. There we go. Don't need all that anymore. And what we're going to do is write the equation if it gives us the zeros. And this is a very specific type of writing the equation. It's only using the zeros. So you'll notice that each problem gives you two zeros. That's the whole point, okay? So on this first one on the left, sorry, you have zeros of negative 3 and 4. The negative 3 is going to become x plus 3, and the 4 is going to become x minus 4. Just like we did on the last slide, but backwards. To make them back into factors, you just switch the sign and you put a y equals in front. Okay? And then what we're going to do, because it says write the standard form of the equation, is we're going to multiply this out, guys. So I'm going to take this x times x and x times negative 4, which is going to give me x squared minus 4x. Okay? That's where I'm getting this part right here. And then you're going to do the 3 times x and the 3 times negative 4, which becomes 3x minus 12. Okay, and I actually think that sometimes seeing it like this, where you don't have to wait for me to write everything, makes it a little bit easier. This is also called FOILing. And basically, you need to take this first one and multiply it by both of these, and then take the second one and multiply it by both of these. Okay? Then I have two numbers here in the middle that can be added together because they're both regular x's. So negative 4x plus 3x is negative 1x, or just negative x. The x squared and the negative 12 stay on the ends. And that's the standard form equation, guys. So you just set up the factors and multiply it out. And then on the next one, I have x equals 6 and x equals 1/3. This is going to become x minus 6. And then let's take a look at why this one became what it did. On the last slide, I explained it's going to be the opposite. And I'm sorry, I made a slight mistake here. I missed my negative when I wrote my 1/3 down. There we go. You guys know I miss negatives sometimes when I'm typing stuff up. But it's supposed to be negative 1/3. Okay, so it's going to be the opposite of this number, the one on the top, and then the one on the bottom goes out front. Because if I were to set this equation back equal to 0, then I would subtract this 1 from both sides, and then I get 3x equals negative 1, and then I would divide by 3, and that's how I get x equals negative 1/3. Okay, that's just showing you that it would work. And I'm just kind of proving it to you there. But it's always going to be the opposite of the top number goes right here. The bottom number goes in front of x. So it's just working the pattern that we did last time backwards. Then I need to multiply this out. So I'm going to take the x times 3x and x times 1, which is going to be 3x squared plus 1x. Oops, I don't know what I just did. Okay, that's where I get this part. And then I'm going to do the same thing, but with the negative 6 times 3x is negative 18x. And the negative 6 times 1 is negative 6. And then at the very end, you add the 2 in the middle together, which is why all of our patterns, when we're factoring, add to the middle. And x minus 18x is negative 17x. Okay, so just set up the factors and multiply it out. Okay, on this very last one, people freak out because there's a lot of fractions. This is going to become positive 3x plus 3, and the 5 is going to go in front of the x, so it's going to be 5x plus 3. Okay, so the number from the bottom just comes in front, and this one changes signs. This one changes signs, the bottom one goes out front. That's all you do when there's a fraction, guys. Because of the way that I showed you, this one would multiply out. And if you need to see more of that, just email me and I'll explain that part again. Some of us trust the pattern quickly. For some of us, it takes a little bit to trust the pattern. Okay? I'm going to erase this real quick because we're about to multiply it out. 5x times 3x is going to be 15x squared. And 5x times 2 is going to be 10x. Okay, so that's where these two are coming from. And then last but not least, 3 times 3x is 9x, and 3 times 2 is 6. Add together the two numbers in the middle, and you're going to get 15x squared plus 19x plus 6, because 10 plus 9 is 19x. Okay, and that's it, guys.